in my sir's notes, there are like a bunch of reactions. Like, for example, he there are quite a few reactions. Sir, like, of, for example, like PCl₅ with some different things. Like, how important are those? Like, are those
Tell
required
me the
chemistry?
reagent. Tell me what you're asking. Give me the reactions
Uh,
directly, no?
PCl₅ plus P4O10 gives rise to 6. Should I see?
So you're talking about PCl₅ plus P4O10,
Yeah.
correct?
Yes.
I'm guessing you're getting product as something like this.
POS. That's it. Yeah. Yeah.
Yes or no?
Yes, sir.
So now, have I ever heard of this reaction? Heck no. But can I guess the fucking product? Yes, I can.
Hmm.
You need to get to that stage.
Okay. Hmm.
You understand the idea over here? Now, in this case here, why was I able to guess the product that directly? Would I have guessed like this if it was PCl₃? No. Why? Because I know for a fact that this is +5, this is also +5. Product is also
Oxidation.
+5.
Oh, okay. Hmm.
There is no oxidation shit happening here. This is just internally displacing each other to get into a more stable scenario, which is like a mixture. That's all.
Hmm.
All I did was that this is going to be phosphorus pentoxide. This is what, this is the anhydride of what? Of H₃PO₄.
H₃PO₄. And
Right?
then
And
H.
H₃PO₄ is going to be something which is going to be a proper +5 acid. Fairly stable
Yeah.
system, very stable acid. Not a problem at all. So now this guy is not really a problematic situation, excepting it is a dehydrated situation. So ideally
Hmm.
speaking, this P4O10 is not unstable. This PCl₅, though, that is unstable. Why is PCl₅ unstable?
Because
If this reaction is
deposited
happening,
fluid.
why is this reaction happening? This reaction
Because
should happen because one of the fellows is forcing the reaction into happening.
yes,
Which
yes,
bugger should force
that's
the reaction
PCl₅.
into happening here?
PCl₅ because it's the one suffering.
Why? I
Yes.
already gave you the goddamn answer, but why?
Is the chlorine atoms are too big?
Hmm?
Chlorine atoms are big,
No, not just that.
not just. Uh,
It's got
+5
two
is not.
different types of bonds, right?
Sir, what?
It's got two different types of bonds. All the
Yeah.
chlorines are not equal there. There are two
Yes.
separate different types of chlorine atoms here, which is
Axial
the real
equivalent. Yeah.
problem. They're not equal. So now they would prefer to go into a system. The chlorine atoms will now prefer to go into a system where they are individually all treated equally, even if they are ill-treated by
Less.
a different atom.
Okay.
You understand the idea here? They want to be treated equally. That's all. Because they are triplets. They are the same thing.
Yeah.
If somebody is getting benefit or not, doesn't matter. खुद का खानदान
All of them.
एक टाइप का ही होना चाहिए.
Yeah.
So you're going to be having the POCl₃ basically is going to be the solution they end up coming up with.
Hmm.
Oxygens don't care actually.
Yeah.
Oxygens
Okay.
don't care much. Oxygens, the P4O10 is not the main cause of the reaction over here. The PCl₅ is the main causative agent of the reaction in this case here. And you get the POCl₃. Now, do you need to know these reactions? No. But should you be
No.
able to get the products? If you're asked, yes. Can they ask you in a JEE advanced paper? Yes.
Oh.
Yes. And can they screw with you even more and make it worse, where they're giving you, say, A plus B gives you C, C with something gives you some other reaction, and something. They can do all kinds of funny business.
Yeah.
So, advanced, yes, it is very much realistically possible that you might get asked questions based on things. But it is not really that bad, sincerely speaking. It's okay. You don't need to really, if you have extra time, you can memorize. Give me a few other reactions. Let's try a few.
There is some weird. Okay.
So this, yeah, you don't need to memorize this, but I think you'll not forget it now this time.
I want to read this time.
Now, next one.
Yeah, this is. So, 3 PCl₃ plus SOCl2.
SOCl2 के साथ. So is this that weird one where you get this S2Cl2 plus POCl3 type of crap?
Not S2Cl2, but POCl3 is correct.
What else is obtained there other than POCl?
PSCl3 plus PCl₅.
PS
SCl3 plus PCl₅.
PCl₅.
Yeah.
No way of guessing this type of shit. And yeah, you don't need to know about these kind of reactions. How many times are you going to be asked these? It's a simple game of probability. Yes, there is a chance that it might be asked, but there is enough chance that there's going to be enough shit in organic chemistry to ask in A giving E, B giving C giving D giving E giving F. Only if they can't find shit there will they ask in this kind of thing. And even in this, you should still be having other ways of getting the other options there. For instance, in this here you said POCl3 is one of the products, then PSCl3, then PCl₅. Correct. I would have probably had difficulty guessing this PSCl₃. I'm still not convinced that we can get PSCl3 and PCl₅. Still not fully convinced. Because here sulfur is going from +4 to -2. And phosphorus you are saying is going from +3 to +5.
Exactly.
I don't think this will happen. I don't think this reaction is correct. My gut feeling tells me this reaction is not correct. S2Cl2 on the other hand, that is realistically possible. Sulfur is going to +1. Not till -2. +4 and the +1 is reasonably possible. But -2, tough. -2 is tough. -2 is tough because sulfur is just a little bit more electronegative than phosphorus, not that much more electronegative. It should not be able to oxidize phosphorus to +5 while reducing itself to the -2 stage. I'm not sure of the products over here. Let me put it this way. I don't trust your answer.
Okay.
So, I'm not sure of my answer also. I'm not saying my answer is correct.
So just a second.
Yeah. Take up. It's okay.
Yeah.
You back?
Yes, sir.
How does this look if I open this now? It just looks like brightness. Okay. Okay. All right. So next, what are the reactions? So this reaction, I don't even trust the reaction whether it's correct or not. So I don't even care about whether it's necessary sincerely. My gut feeling is that it is really not needed right now. What else? Next up, next reaction.
C6H5N2Cl plus H₃PO₂.
That's needed. Not here though, in organic chemistry.
Organic. Okay.
So what is C6H5N2Cl?
That's diazonium
Yes.
fluoride.
H₃PO₂ के साथ, this is going to be a fairly interesting and important reaction. You'll end up having this guy undergoing oxidation, and you'll end up having product basically becoming phosphorescent +3 or sometimes phosphorescent +5 also. But this fellow, the benzene ring will undergo reduction here to give you product as benzene. You get benzene and you'll get phosphorus either in +3 or phosphorus in +5, depending on the hydrolysis stage which you're using. What is the answer?
Hmm.
What is the equation required there?
It gives two benzene plus H₃PO₄ plus N2 plus HCl.
So you're going with
Yeah,
phosphorus in
plus
+5.
5. Plus
So
5, yes.
H₃PO₄ is what they're going with. N2, of course, is going to be coming out.
Yeah,
All your
N2,
diazonium
yes.
reactions will give you N2 gas.
Hmm. Okay.
Hmm. I'm not so sure though, because I remember literature where we do get H₃PO₃ also. Both are obtained. So not
Hmm.
100% sure if we get only +5 there, because my gut feeling tells me H₃PO₃ is also obtained partially. Not so sure. But so, chalo, that doesn't make a difference. But yeah,
Okay.
next up. This reaction you don't need in this chapter. So you don't care about it here. I'm being
So
very
then,
sincere.
how do I know
You
which
need to care
ones
about
like?
it in benzene, not here. In benzene, you care about it. In inorganic, you don't give a shit about it. They should
Hmm.
not ask you this in inorganic. But I think you have phenols and benzene, diazonium chloride, and shit, nah.
No, sir, only alcohol.
Only alcohols. Then yeah, you don't need to care. You should not care logically. Next,
So
not for
how do I know which ones to study
which
and to
one?
care about? How do I know which ones to care about and which ones not to care about?
I think I already told you, no. You don't need to give a shit about your teacher's notes at this stage. You need to care about only NCRT at this stage. Because at this stage here, you should not be preparing for JE Advanced.
Yeah.
Preparing for JE Advanced, teacher's notes alone are not enough. You need that plus a little bit of extra supplementary also. So, how do you decide? Choice is very clearly made. Now you are reading this so that you get an edge in your internal exam. So, sincerely speaking, in your internal exam, nobody can guess it up. Depends on who is setting the paper. Okay, घाट में कितना problems है, irritation है, how irritated is that person that they have to take it out on the students. Depending on that, उसके हिसाब से काम होगा. Now anyway, next up, give me a few more reactions. Let's quickly at least discuss off, make it snappy and faster so that we can quickly talk about which ones you need to bother so much about and which ones you don't need to worry so much.
So TeF6.
Tellurium, you don't need to give a shit about anything.
Okay. KMNO4 gives rise to K2MNO4 plus MnO2 plus O2.
KMNO4 gives you K2MNO4, MnO2 and O2.
Yeah.
Decay of KMNO4. Thermal decay.
Yeah, exactly. Yes.
Yeah, you need to
Preparation
know
of
that for sake, but not in this chapter. Which chapter
oxygen.
are you doing now? Group 15 and group 16. Like, why the hell do you need this over here? Oh,
Preparation
production
of
of
oxygen.
oxygen. Yeah, production of oxygen. You don't need to know all the individual products there, but remember it like this: any oxidizing agent, if you heat that sucker, it will produce oxygen gas.
Nitrogen also, sir.
Basic game there. That's why it's
Same with
called an oxidizing agent. You heat the fellow, that oxidizing agent will somehow or the other produce oxygen gas. That's the game there.
Same with nitrogen.
Of course, nitric acid will basically, on heating, give you what? Nitrogen dioxide gas and oxygen gas.
Yeah.
Next up, water also, of course.
Water, yes. Yeah. Sir, PCl3 plus 3LiAlH4 gives pH3 plus LiCl plus.
Is that a problem
It's
really, or is it obvious? It's
pretty.
obvious, no? You're doing alcohols for God's sake.
Yeah. Okay. My bad.
It's not your bag. You just need to start thinking about inorganic
Yeah.
the same way you think about organic.
I
You have to
couldn't.
start
Okay.
applying common sense. So if you're having PCl3 reacting with LiAlH4,
Reducing agent. So
reducing agent. It will give you pH 3, quite
okay.
obviously. And what will happen
Yes.
to the chlorine? So you go for the lithium and the aluminium. So you get LiCl and AlCl3. Job done.
Okay. Yeah. That was the part.
Next
Okay.
up. Hmm.
Uh, P4 plus HNO3 gives
Now
H3PO4
stop,
plus
stop, stop,
NO3.
stop, 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 stop. P4 plus HNO3. How do you proceed here and understand the reaction? Now H3, HNO3. What type of a substance is HNO3? Powerful goddamn oxidizing agent.
Agent,
That's
yes.
its
Oxide.
identity.
Yeah.
Yes or no?
Yes.
So its identity is it is the biggest, one of the biggest oxidizing agents, one of the biggest bullies around.
Hmm.
What will it do? It will extract all the electrons from phosphorus. Phosphorus will go from 0 to +5. +5, what is the stable form of phosphorus
Four.
available?
Pure.
H3PO.
H3PO.
But depending on the amount of water available, I'll be getting H3PO4. If not H3PO4, what are the other stable +5 forms of phosphorus we know? We have H₃PO₃,
HPO3, yes.
which is an anhydride version of this, and you
Yeah.
also have P4O2.
Hmm.
So these are the possible products with HNO3,
Okay.
depending on the amount of water available in the medium. Now, what will happen to the HNO3 once it has done its job? Depending on the amount of HNO3 available, I will have the products also obtained, correct?
Yes, sir. Yeah.
If I have enormous amount of HNO3 available, what will happen in that case?
The all of them could form.
Mhm. So think of
All
it like
together
I have huge amount of HNO3. What does huge amount of HNO3 really indicate?
will stay
Hmm?
excess. Excess.
Excess. What does excess
I mean,
also indicate here as another possible way of looking at it?
it'll
Concentrated as
remain.
another way of looking at that shit there.
Ah,
Correct?
yes. Yeah.
Now, if I have concentrated HNO3, that basically means I'm going to be having enormously large amount of HNO3 available per unit volume.
Hmm. Yeah.
So, what will be happening here? I'm having a large amount of nitrogen in +5.
Hmm.
So, each nitrogen in +5 will be having just about enough time to go give a smack to the phosphorus. Take some electron and go away. They'll do some conveyor belt type of shit.
Hmm.
Why? The problem there is this. NO3 minus becoming NO2 is one thing, where the nitrogen in +5 is going to become +4.
Hmm.
Then what happens is this NO2 can still go and end up becoming nitrogen in +3, which can still go down and become nitrogen in +2, then nitrogen in +1, and so on and so forth.
Okay.
But for the nitrogen to go in this process till this end over here, it will do that only if all of the NO3 minus are gone. NO3 minus is the biggest bully.
Hmm.
Only after all the NO3 minus are satisfied will the NO2 start doing its shit. So if I have concentrated nitric acid, all of
Yeah.
my reactions involving concentrated nitric acid will end with NO2 gas. Why?
Okay.
Because I have a tremendously large amount of NO3 minus available in the medium.
NO3 minus. That'll get oxidized.
So
Yeah.
the
That'll
biggest
lose.
bully will be the only fellow who will keep doing the reaction, oxidation reaction.
Hmm.
NO2 will not get a chance. NO2 is a reasonably good oxidizing agent, but not good enough. Not compared to NO3 minus.
Yeah. Hmm. Makes
But
sense.
so if I have concentrated, I'll be getting products as H₃PO₄ and NO2, main products.
Hmm.
Other products are loose fellows, we don't care. Water, shit, I don't care. These are my two main products, depending on the amount of water. If I have concentrated, the problem is this though. Do I have water or do I not have water?
No, we don't have.
Good. So will I get H₃PO₄ really? H₃PO₄ is with water,
Yeah.
correct? What
Yeah.
do you think I'll be getting? There is a little bit of water, because HNO3, when it does end up acting as oxidizing agent, NO2 mil jayega, oxygen nikal jayega, but you get a little bit of water out there from
Yeah.
the nitric acid itself.
Hmm.
So I don't have a chance to get P4O10. P4O10 is like destroy, nothing, no water, nothing like that.
Yeah.
So like
Completely.
I get this sucker. So if I have to write the reaction between P4 and HNO3, what would be my guess to get the products over there? If I was given concentrated nitric acid, how would I guess that? I will say it will probably give me H₃PO₃, and it will give me NO2 gas.
Hmm.
If it is dilute HNO3 though,
Sir,
then
just a second.
yes, ma'am.
Someone's at the door.
Please. Okay. So when you're going to be having dilute nitric acid here though, you're going to be having conditionalities appearing there. Nitrogen is still powerful, either in the NO2 stage or in a nitrogen +3 or +2 or +1, whatever it is, it's quite powerful as an oxidizing agent. So you will still be getting phosphorus going till like say H₃PO₄ or H₃PO₃ stage. In this case, mainly it will be going to H₃PO₄.
Hmm.
1 second.
Yeah.
Typing already. Yeah. So you're going to be having H₃PO₄ obtained here mostly, but at the same time, the other product can be NO, N2O, and if you are having extremely dilute nitric acid, the usual product obtained will be ammonia or some kind of ammonium salt, usually. If you are having extremely dilute nitric acid used as an oxidizing agent. You have group 15 this time, na?
Yes.
So let me just quickly give you this is basically nitric acid, not phosphorus now anymore. So if you're looking at reactions of nitric acid, concentrated nitric acid will only give you NO2 gas as a product.
Hmm.
Reduction. Dilute nitric acid, depending on the amount of dilution and the other player, the other substance which is undergoing oxidation there, can give you anything from NO, N2O, N2, and NH4 plus.
Water.
Not water. NH4 plus. Nitrogen is the one which is undergoing reduction, nada?
Yeah.
I'm only looking at nitrogen.
Okay. My bad. Yeah.
So it can go from +5 to +2 to +1 or 0 or -3.
Hmm.
So the most dilute form will generally go for this. So for instance, when will you get that NH4 plus? Zinc. If I'm hitting it with say very dilute nitric acid, or say iron, it's a very dilute nitric acid. In that case, there is a
Ammonium nitrate.
chance that I might end up getting NH4 plus.
Yeah, it was given. Yeah. Yes.
Sorry?
Yes, sir. Yeah.
You understand the idea here, right? So it depends on what you're using over there. Zinc and iron, of course, will undergo oxidation over there to become the corresponding +2 ions over there. Iron might
Yeah.
also become the +3. Depends there.
Yeah. Yes, sir.
You're going to be having this analysis basically is going to be applicable when it comes to nitric acid. If it's more diluted, the more it will go towards a lower oxidation state. If it is in more concentrated form, it can do nothing. It will, because the biggest bully is NO3 minus. Other NO3 minus will basically end up clogging all the electrons. They will not let the NO2 or the other forms take the electrons. NO3 minus will take the electrons exclusively. It's basically the same as acid base. Acid base, what is happening? We have discussed this before once or twice, I think. If I have a mixture of acids and I add a base, which acid will react with the base? Which acid is strongest will react first, correct?
Yeah.
Why? Because it is absorbing protons over there.
Exactly.
What is being absorbed here? You're having electrons getting absorbed. It's the same basic principle. In
Yeah.
that case, protons are absorbed. Here, electrons are getting absorbed. Nothing else.
Yes.
Same
Yeah.
game, but different substance is getting absorbed over there. Different subatomic particle is basically getting absorbed effectively. So in both cases, the same principle applies. When you are going to be having multiple sharks, the biggest and the strongest shark eats first. As simple as that. Now, next up, what other reactions have been frustrating you? Nitric acid, I can understand.
Yeah, there are a bunch of nitric acid ones.
I think this should sort out a reasonable number of your nitric acid queries to some extent at least. And how you should remember nitric acid reactions for redox is you should only remember the redox part. If you're expected to get the other products over there, you can always balance the shit out, redox balancing over there and get the job done. Do not remember final reactions, only remember the redox products there. That is, what does nitrogen become? What is the other fellow becoming roughly? If the other fellow is guessable, don't even remember that. Only remember what nitrogen becomes. That's it. Job done.
Yeah.
You understand?
Especially the ones with like when you're reacting with metal, then you would only have to check which state the actual metal thing is.
Correct. Yes.
Okay.
So if it's going to be lead or copper, I don't need to give a shit. I know they are going to go into +2 only. They're not going to go into some superior state over there. They're going to go to +2. So how does it matter what they're going to be doing there? I just need to know what the nitrogen is going to become mainly.
Okay, yeah.